L'Hopital's. We got it now, L'Hopital's. It's like a L'Hopital's, just like what it says, L'Hopital's rule. So you will like this section because the section gives you power to figure out what limit is. Before, you have to know, you have to do manipulation algebraically, otherwise you cannot find your limit if this is what? Infinity over infinity or zero over zero. Those kinds of stuff we couldn't do. But now we have a new tool, right? New rule, L'Hopital's rule, so we can, our life become much simpler. All right, objective. Recognize limits that produce indeterminate forms. Apply L'Hopital's rule to evaluate limit. Indeterminate form. Indeterminate means what? You cannot determine, right? That's what called indeterminate. So for example, you have a 0 over 0, or infinity over infinity. You cannot do your problem. That's why you have to do what? Make this into, factor this, so you can factor. Remember, we have to do the factoring.
That's the
for this
algebraic
case.
part.
Yeah, you have to do factoring, which is x plus 1 and x minus 1, and then you're going to say, okay, I can cancel this one out. That become a 2x minus 1. Remember, we have to do that? So this requires a lot of algebra. If you're not good at algebra or you cannot remember your factorings, you will make a mistake on this, right? Because 2x squared minus 1, if you plug it in -1, you get a what, 0 over 0, which you cannot solve your limit. That's why you have to rewrite this problem into what? Factoring, two factors, and then you go to I will divide by denominator x plus 1 and numerator x plus 1, and you just left with what? 2 times x minus 1. But now we don't have to do that. We got a new rule called L'Hopital's rule, so we can use that instead of doing that. So we will use derivatives instead of that. Same thing here. If I plug in 0 here, you get 0 over 0. You cannot do that. You cannot find your limit. But watch this one. So now here's the what? L'Hopital's rule. Let's come up here. So L'Hopital's rule is to find the limit illustrated in figure. This you can use theorem called L'Hopital's rule. This theorem states that under certain conditions, the limit of the quotient fx over g of x is determined by the limit of the quotient of the derivatives. Did you see that? Now my life gets much easier because I can just take a derivative of f, derivative of yg, and then plug it in, the x value. Whatever the x value will give you your limit. So this is going to be your limit. So they're telling you if you have, when you plug in x equal to this number, to f of x and g of x, you get a 0 over 0, what infinity over infinity, what negative infinity over negative infinity, what positive infinity over negative infinity. All this situation, you can use L'Hopital's rule. Are you with me, class? So whenever you have a 0 over 0 or infinity over infinity, then you're going to say, okay, I'm not going to do the algebra manipulation. I'm going to use what? L'Hopital's rule. So look at this problem. For example, let's just strictly plug it in. What do you get? If I plug it in, what do you get? 0 over what? E to the 2 times 0 minus 1, what do you get? 0 over 2 to the 0 minus 1. What's e to the 0? 1 minus 1, you get a, what do you get? 0 over 0. So now, what can I do? I can use what? L'Hopital's rule. Are you with me? Your limit is not 0. Are you with me? 0 over 0 is not 0. So you're going to say, since you have this, what can I say? I can use L'Hopital's rule.
Right.
So I'm going to say, I can rewrite it as okay, take a derivative of this. What's the derivative of this? E to the 2x minus 1 times what? Derivative of, what's the derivative of 2x minus 1? 2, right? Are you guys following me? So if I give you f, what is f prime? E to the what? 2x minus 1 times what? Derivative of this, what's that equal to? 2.
Alright.
Are you following me, class? Okay. The other one is what? If I say g of x is equal to what? X. What's g prime? Just 1. Am I right, class? Are you following me? Because I have this over what? That. The L'Hopital's rule says if we have a 0 over 0, which we got it, right? The f and g is equal to what? 0. We don't want it got a 0 over 0, so we can use what? L'Hopital's rule. Are you with me, class? So you're gonna say, okay, that means, oh, now I know what to do. That really is just simply means what? Now I can plug it in. So this is E, 2 in the front, and I plug in 0. Are you with me? So you're gonna say, okay, so that's equal to E over what? 2 over E. So that is your limit.
First, you gotta make sure it equals 0 to 0.
Right, I cannot just use L'Hopital's rule. You have to make sure when you plug it in your limit, that gives you a 0 over 0 or infinity over infinity, then you can use L'Hopital's rule, all right? So when you use L'Hopital's rule, what do they say? I can rewrite it as what? I can find this. So I'm using this as my numerator. I'm using this as my what? Denominator. So we just found it. What is my limit when I have this? What's my answer? What is my limit over here then? Limit is what? 2 over what? E. See how much easier than that? Because like I have no idea how I can do this algebraically anyway. Are you with me? So because of L'Hopital's rule, now I can find limit easily.
That's not algebraic technique.
No, I didn't do that. That's right. We just use differentiation, right? Differentiation is much easier than trying to manipulate algebra stuff. Because like if you have a very complicated polynomials, you have no idea how to factor. Is everybody good? All right. So we can move on. What did I do? It says a 2. Oh, class. I use a 2 as what? X minus 1. That's what I did. But the problem is what? 2x minus 1. That's the problem they had. But don't worry. So if you do this way, you get 2. If you do problem like that, what do you get? 2 over E.
Oh,
Do you see the difference?
Yeah.
The problem that I did was what? 2 dx minus 1. The whole thing is by power. All right. So this one, let's do one more, and then we're gonna do your level sign problem. Because I'm not gonna go further. Because when you move on to lesson like slide 27 and 28, it gets very complicated.
Yeah.
But I don't give that kind of homework problem. So I'm gonna skip those. I'm gonna just come to your homework problem.
I stopped at
Because that's very, very complicated.
I did 20.
All right, so let's see it. First thing first, if I strictly plug it in, what I get? Infinity over what?
Infinity.
All right, natural log infinity, and that both give you what? Infinity over what? Infinity. So can I use L'Hopital's rule?
Yes.
So I'm gonna say my f is what? Natural log of x. What's my f prime?
1
1
over
of
x.
x. G of x is equal to what? X. So g of prime is what? 1. So does everybody agree? So I can rewrite this problem as limit x approaches to infinity, and then I'm going to write down which one? 1 over x over what? 1.
So Dr. Hughes,
Yes.
we have to do that first step. It seems like the purplish color, we gotta do it first.
Right. We need to
in order
make
see.
sure it is either infinity over infinity or 0 over 0.
Oh, okay.
If it's not this case, you cannot use L'Hopital's rule, okay?
Okay.
L'Hopital's rule only works if it's what, 0 over 0, or infinity over infinity, or negative infinity over infinity, or positive infinity over negative infinity, something like that, okay? But if you have some number, no, you cannot do that, right? Say if you have, like say, well, if there's some number, you know what to do. In that case, you don't have to worry about it anyway. You already found your limit. All right, so now can I plug it in here? Then you get a 1 over infinity over 1. 1 over infinity give you what? 0. 0 over 1 give you what? 0. So your answer is 0. So I found my limit. This will gives me what? 0.